Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week, and this has been a bit of an unorthodox week with regard to the bonus videos. Bonus weather video number 1, which normally comes out Monday, was not out until Wednesday morning. Bonus weather video 2 was out Wednesday evening, and then bonus weather video number 3 is out today on Thursday instead of Friday. And that's because I'm going to be on the road going to Asheville tomorrow to prepare for a concert that the band I play in down here is doing at the Biltmore House on Sunday afternoon. So it's going to be rather difficult for me to do a whole lot weather-wise tomorrow, and so I thought I would just get this out of the way so we can fulfill the bonus weather video quota for the week. All right, let me put myself down here. I've entitled this Local Variations in Temperature and Why Do They Occur? So let's start off with talking about some smoke and mirrors with temperatures and forecasting. So when you look at my 7-day forecast, do you actually believe that I believe everyone in the triangle will experience exactly the same high and low temperatures? I hope you don't think that, but if you did, then let me rest assured or tell you that that is not the case. I'm very aware of the fact that things do vary from spot to spot. There was a time many years ago that a range of temperatures was given. You'd see this on TV, hear it on the radio, see it in the newspaper, but then some folks decided that a single number sounded more accurate than a range, and so that policy was more or less adopted. The reason I give a single number is that I'm verifying my forecast at a single point, the Raleigh-Durham Airport, but I remain acutely cognizant of variations in temperature across the region, especially at night. So what causes these variations? Well, soil moisture and type is huge. Supposing it's July and one afternoon this isolated thunderstorm pops up and just dumps on you, okay? And you get 3 inches of rain in about an hour's time. Nobody else anywhere within a 30-mile radius gets anything, okay? But you get dumped on. So when the sun comes up the next morning, initially most of the energy from the sun is going to go into evaporating the moisture in the soil, while nearby areas that didn't get any rain heat up more rapidly. Evaporation is a cooling process, and so as a result, and by the way, you all know that when you step out of the shower or step out of a swimming pool, you feel chilly. And so that's what happens here, is that instead of that energy going into heating up the soil, it goes into evaporating the moisture first, and then once it's done that, then it can start heating the actual soil temperatures or raising it. So as a result, your area will probably end up being a few degrees cooler that day than everybody else because they didn't get rain and you did. So your local area, again, may experience just a slight cooling anomaly compared to everybody else. And then in terms of type, lighter textured soils such as sand are influenced by sunlight to a much greater degree. And so diurnal temperature ranges from day to night are usually much larger. Out in the desert, you can sometimes get a 50 or 60 degree spread in temperature from the daytime high to the nighttime low because of this very thing. And when you have a heavy clay type soil, then that process is not nearly as efficient, okay? So I remember, now this doesn't have anything to do with temperature, but I remember after Hurricane Fran, I talked to a professor over the Department of Forestry at NC State, and I wish I could remember his name. I can't remember it offhand, but he was explaining to me that the type of soil we had in central North Carolina was the type that when it became saturated, it took on the consistency of a pancake batter. And he said, you don't need 150-mile-an-hour winds when you have trees sitting in pancake batter to bring them down. And if you were here for Fran, you may remember that most of the trees that were down, you could see the entire root ball, okay? So it's not like the trees were snapped, at least not in many cases, but the entire root ball was visible because the soil was so wet, and it took on the consistency of pancake batter, and you had 50, 60, 70-mile-an-hour winds all night long, and it brought down an awful lot of trees. So again, the soil can really play a big role in a number of different ways. Now, compacted soil will stay cooler as sunlight is unable to penetrate that entire soil layer. So a less dense layer of soil is going to heat up more rapidly than a compacted soil. And a lighter color soil will reflect more of the sun's energy. You might have heard the term albedo, where the lighter the color, the more it reflects the sun's energy. Freshly fallen snow reflects 95% of the incoming energy from the sun. whereas a dark black surface, like maybe an airport runway or something like that, is going to absorb that energy much, much more efficiently. So the color of the soil plays a big role as well. And then, and I had a chance to actually experience this a couple of times, there's a place called the Pine Barrens in central Pennsylvania. It's about 4 statute miles northwest of State College, where Penn State is located. And it basically has a unique combination of topography and also soil type that allows it to be one of the coldest spots in the entire state. And so here are some interesting stats. Now the high temperature is not that different, okay? The number of days at or below 32 in State College is 63 days, 17% of the year. And in the Barrens, it's 69, 19%, not a big difference. But when you take a look at the minimum temperature, this is when it gets crazy. The minimum temperature less than or equal to 0, on average, only occurs 1 day a year in State College, but 31 days out in the Pine Barrens. And the number of times the low temperature is less than or equal to the freezing mark is 135 days in State College and 206 at the Pine Barrens, okay? And I remember going out there in the summertime in August and seeing frost, okay? Whereas downtown State College, it was in the 50s, all right? So I'll tell you an interesting little story about this. The President's Day storm, the first one that affected the entire East Coast back in February of 1979, there was a huge area of Arctic high pressure over the northeastern part of the United States. And we knew that the coldest temperature that had ever been observed, and of course they don't take daily observations, so there may have been days it was even colder than this, but somebody did a study back in the 40s and they had one night where it was 40 below 0. So that was sort of the benchmark, okay? And so a friend of mine who was a senior at Penn State, he and another guy who was also a good friend, decided to do a study. So they took these Taylor max-min temperature sensors or thermometers and layered them like 6 feet above the ground, 5 feet, 4 feet, 3 feet, 2 feet, and 1 feet. Because at night, if it's clear and calm, the coldest air will collect near the ground, then it'll gradually get warmer as you go up. So they wanted to study that over the period of an entire semester. So the thinking was that that night we had a shot at getting to that 40 below 0 reading. And so a whole contingency of students went out there, and at 1 o'clock in the morning, it was 26 below 0 already, okay? But then the cirrus clouds in advance of the President's Day storm came in and the cooling abruptly stopped. And so we didn't even get close to that 40 below 0 that night. But there were a bunch of crazy people, of which I had a lot in common with, that spent the night out there hoping against hope that they'd be able to see a record, but it did not work out. But that place is truly amazing. And apparently it was rather ravaged by, oh gosh, I can't remember the whole story right now, but apparently the land surface was pretty much ravaged over a period of time. And as a result of that, there wasn't much vegetation left. And the problem was then at that point, it got colder, and so it was tough for the vegetation to regenerate because the environment was so hostile. I think I can give you a link. I'll put down underneath the video a link to some information as to how all of that happened back in the 1800s that you might find interesting. All right, that's it for now, folks. You all have a great Thursday evening, what's left of it, and we will talk to you again tomorrow with the daily updates. It's going to be late in the day, maybe even into the evening, because I'll be on a chartered bus heading to Asheville. Nonetheless, I will get something to you at some point in time. Okay, that's it for now. Take care. Talk to you soon. Bye-bye.